I let Martin took some of my time because I think it was a great introduction for my talk. I'll basically repeat whatever he just did in JavaScript. All right. So today I'm going to talk about one of the most exciting things out of the TensorFlow summit this time is that the group has released TensorFlow.js. So right now, all the stuff that you could do with TensorFlow Python, now you can do a lot of things in your web browsers. All right, my name is Ta, and I'm also the other GDE here, based in Thailand, and I'm also a founder of a company called Studio. All right, and most of the slides today, if you're worried about taking photos and everything, it's actually from the TensorFlow Summit, most of them, so you can grab those online too. All right, so over the past few years, at the very least, Python has been the leading language for doing machine learning and, in particular, deep learning stuff, and that is changing. How many of you here is actually a JavaScript developer? Node.js, React, Vue? Oh, OK, not quite a lot. I was hoping at least a half, but OK. Today we're going to talk about JavaScript, unfortunately. OK, this is the point where I have to ask, have any of you seen this? But all of you have just saw it, all right? So this is the tool that's built based on JavaScript. It's the playground. It has huge educational value. Every single time when we teach deep learning stuff, everybody always resort to this playground because of its interactivity, your students can come on and play around with the parameters and kind of see how adjusting a certain parameter affect the final outcome of the model. So it was great. It was awesome. It works everywhere. It works on your mobile phone, and everybody loved it. So it was a great example of why we want to do machine learning in browser. So first of all, no drivers, no installs. You can go to that website, open it up. It works on your phone. It works on anybody's laptop. And as Martin mentioned, whenever we run a workshop, we generally spend at least half an hour, if not 3 hours, trying to get everybody to be able to install every single libraries that we need to get things up and running. So without needing any specific drivers or installations, this is a huge help for us to do a lot of things with machine learning. The second thing is interactivity. As I said, a lot of time, you kind of like want to play around with your model. You don't have a great idea yet of how your model should look like. You kind of want to play around with the parameters, or sometimes you want to play around with your input, kind of like playing around with your input and see how different input affect the outcome. And with web-based UI, things are much easier. You can play around. You can understand your model much better and build a lot of application through GUI stuff. The third benefit is that once you manage to get everything run on your browser, you can open it on your mobile phone. And with mobile phone, you get a lot more input that you can play around with. You now got GPS signal. You now got microphone. You now got accelerometer. You have camera. You have gyroscope. So imagine all the AI applications on your phone based on all this data. You can kind of like build a game or something, playing around, take all this input, and make some kind of predictions or inference. And the third one, which is also a huge value to do machine learning in browser, is privacy. Imagine you're a big company. You kind of want to learn about your customers' behavior. You basically have to track every single click they do on the page. OK, they click on that. They look at this website. They look at this link. They look at this particular photos. They share this. They like that, right? So you basically have to track every single click, send all this information back to the server. It's a lot of work. But with all this, you can simply send the model to the client and let your users do whatever they want, and then use the data within that browser, do some inference and run some machine learning model on that. So this is another value of doing machine learning in your web browser. All right, but for this project, it was then built as a one-off project. So it was custom-made. It's like a lot of for loop, basically. Write neural network from scratch using all the basic operations of JavaScript. So they think it's probably not going to scale. And if we manage to give people this ability to do machine learning with JavaScript on browsers everywhere, that should be great. So that was the beginning of this deeplearn.js project. So the project was actually pretty new. It was released just August last year. And the cool part of it is that your web browser is already connected to WebGL stuff. So you basically get GPU accelerated capability to kind of run all your machine learning model through your web browser. And basically, with deeplearn.js, you can do inference and training entirely in your web browser. And that is huge. And just from that August 2017, they actually released tons of demos and applications and tons of things that you can do on the web. And I will go through some of the example. I'm sure a lot of you have seen style transfer. But instead of sending your photo, maybe 3, 4, 5 megabytes back to the server, let your server run, send back another image 3, 4, 5 megabytes, and do this every single time, why don't you just run this on your browser? You don't have to send your photos back to the server every time, especially if you want to do style transfer on your, say, your selfie. You probably don't want your photo stored in server somewhere, right? So I'm going to show you this demo. So basically, I've loaded this model. This is the style from one of the artists, Francis Picabia. I think I just ruined his name. You pick the style. You can pick a photo that you want to transfer the style to. Hit start, and hopefully it runs. Ta-da, and you got it, right? And you can actually play around with this if you like. Now I'm going to sacrifice myself. All right, take a pic and draw me something. Yep, there you go. And you got myself transferred into this style. And there are a bunch of models that people already built you can play around with. If you want to get your selfie in Picasso style, you can also do that. And it's going to take another few seconds. And there you go. And all this data, my photo, never leave my computer. All right, that's the first application. OK, the second one is this one. Has anyone seen this? It was viral for a while, maybe not among you guys. OK, but this one basically, they want to demonstrate what we call generative model. Generative model is a model that you learn from tons of input, and you can generate a new samples, a new set of samples, new data point, basically. And basically, for this particular application, you pick your starting font. I want to start with this font. And I kind of want to see if I want to make it bold, maybe super bold. How would that look like? What about a bold font and somewhat italic, too? How does that look? So you can do all this. A lot of you might think, this shouldn't be that hard. You just tilt everything, and you get italic font. You can just explode the black area, and you get all the bold font. But actually, graphically, if you want to get something beautiful, it's not done that way. So this is the example for these two fonts, Georgia and Helvetica. If you do naive bolding, you basically expand the black area. You would get something that looks like this. But if you're a designer and you want to make a bold font, that's not how you do it. You do it this way, the rightmost column, and you can see you just expand certain area of the font to make it look stylistic and nice. And for this particular work, they're basically trying to do just that. So they basically try to learn all this. And once you learn the style of the fonts, you learn characteristic of the font, you can start doing fun things like I want to combine the style of this font with the style of this font. And I can put a weight. OK, I kind of wanted to make it rounder and rounder. And the outcome would look something like this. What if I want more on the left-hand side? It would look something like this. But somewhere in between would make it a bold and sort of round font. So once you learn the style of something, now you can start mixing it up and do a lot of things with that. And again, this all done on your web browser. And OK, the rest I won't demo. Some of you might have seen this teachable machine. Basically, you can train 3 actions with your webcam. You do whatever on it, train 3 actions, and then you can start doing prediction right in your web browser. They also released this. You can control arcade game with your photos. You basically have to train all these actions, like no actions, arrow up, arrow down, arrow left, right, and I'm trying to play Doom. I'm not sure if the audience in this generation know this game Doom, but it was once very, very popular. So I tried playing that. I tried to shoot that barrel, and I eventually did that. So these are things that people start building using deeplearn.js. And as I said, it just started in August 2017. And we got tons of examples of cool use of this library. So we think it's actually a really good idea to actually give people this capability. So in the latest TensorFlow Summit, instead of announcing what else deeplearn.js could do, they basically merged and started what they call TensorFlow.js. And this would be the topic of discussion in my talk today. So what you can do with TensorFlow.js. First of all, you can author models directly in browser. And by author models, I mean you can create a model, just like when you use TensorFlow in Python. You can create layers. You can create tons of tensors, add a bunch of operations, and create the whole model and train it and use it right in your web browser. The second thing that you could do is, OK, a lot of people already talk about style transfer. A lot of people already talk about we don't really need to build a new model from scratch. Why don't we just use whatever existing model that people already built? We just load the model and just use it for inference. So this is also a good application, as I said, because you don't have to send a lot of information back to the server and send a huge information response back to the request. And the last part is to kind of combine the two. You import the model, but you want to do style transfer. So you want to retrain part of the model. You want to retrain just the tail part of your model. So this all could be done using TensorFlow.js. And OK, basically, as I mentioned earlier, because your browser already connected to the WebGL, so you basically have access to your graphic card to WebGL. So if you have a very fancy graphic card, you can run this very quickly on your web browser. And there are 2 sets of APIs that they released. The first one is called Ops API. Some part in the doc, they would call it Core API. But basically, these 2 are the one that equivalent to TensorFlow model. So basically, if you wrote TensorFlow before, you should be able to do the same thing using JavaScript, if you know JavaScript too, very easily. And in the parentheses, it says eager, and that's what Martin just talked about. So basically, they try to make the APIs consistent. So all the syntax, all the commands in TensorFlow.js would look pretty much like the TensorFlow Python in the eager execution mode. And we also have a higher level API. So for those of you who use Keras a lot, you build a model based on pre-constructed layers like dense layer, LSTM, RNN, CNN, those kind of stuff. It's also available for you to use as well. All right, so I will go through some of the demos. I use this notebook. It's a JavaScript notebook. I believe most of you probably haven't seen it. But if you open this link, you should be able to run it, except some of the part that I need to fix my JavaScript to get it to run well on your phone. So if your phone crashed, don't blame me. All right, let's see. So first, I will go through the first use case of, OK, let me zoom in a bit. Okay, this seems to work. Okay, so the first use case that I would go through is how to write a model in your web browser, train it in your web browser, make prediction in your web browser. So first of all, you can simply import the TensorFlow package to your environment, depending on how you use JavaScript. In this case, I use required. But if you, let's say, if you include it, you can also include it as script, which is distributed through the CDN. So you can just do script source and put the link in there. Or if you use NPM or Yarn, you can just do import star like this in your project. All right, once you import it, okay, the first part, I'll start out by generating some synthetic data. The point of this is to demonstrate how tensors work and how ops work, and basically just to show you that this is pretty much like random data, assuming that I'm a user generating some random data point on my web browser that I'm about to use to train a model. So you can play around with all this. Okay, so I basically assume that this is a cubic function, polynomial, third-degree polynomial, okay, with all these coefficients. Okay, I kind of want to do something that would make my life easier later on. So I'm going to make some function that's sort of easy to predict. Okay, something like this should be good. All right, now your user generates some random data. How does it work in the back? So basically, if you used TensorFlow before, it looks something like this that you're familiar with. You can generate tf.scalar to take in all these numbers and make it a scalar number in TensorFlow. So you call tf.scalar. You can generate random variable using tf.randomUniform. They also have tf.random normal and many other distributions. One thing that I think it's really cool is if you write JavaScript, you do a lot of function chaining. And by function chaining is, I call this, it would return one tensor, and I would take this tensor, add this tensor inside, and then add, and so on. So you can kind of like call things continuously. And I believe this syntax also available in Python eager execution as well. So you can chaining all this function. So basically, here I just write down this equation. So it is y equals a times x to the third, b times x squared, c times x, plus d plus some random noise that I want to generate it. All right? And then, okay, this is it. That's the function to generate input data. Now also, just to demonstrate a little bit about the operations, later on, we will need to use this mean squared error loss. So I create this function called loss, take predictions and labels, and then subtract to get the differences, and then squared, and then take the mean. And this would be the function that we use to compute our objective function for the model. One thing that I want to point out that I kind of separate this part as an example is that you can see me call this tf.tidy right here. So when you do create tons of tensors on your web browser, chances are you leave some of them hanging, and basically you back to your C++ world. You're going to have memory leak. So tf.tidy is a handy function that whatever you wrap inside, it would clean up all the tensors in there after it finished executing that function, except the one that you returned out of that function. So try to wrap everything with tf.tidy so that your browser won't crash. All right, now you have the basic setup. You have the data. You want to start training the model. So the first one, I will show you how to train a model using the core API or ops API. So I will update my input first, and the graph should show up. Okay, it's super fast because in this model, I just try to fit this four number, A, B, C, and D. What should be these four numbers? So with the interactivity of JavaScript, you can kind of play around with your model. So let's say I would say, okay, what happened if I train this with way fewer iterations. I reduced it to 14 right now. OK, it actually changed already, but not much change. Oh, I need to update the model. OK, sorry. OK, if I do 2 iterations, it's still pretty bad. 6 iteration, getting better. OK, move up to 28. It's probably really good already. If I move all the way to 88, OK, it fits slightly better. So you can play around with your model and kind of see the result almost right away. So now let's see the code a little bit. If you write TensorFlow before, this should be a breeze for you. You create variable just like in Python, tf.variable. You can initialize it with anything, with random number. In this case, I just use 0 to initialize the 4 variables that I want to predict. And then I create this model f, which is basically this polynomial function. You specify optimizer, and it looks very much like what you would do in Python as well. In this case, I used SGD, stochastic gradient descent, to solve this optimization problem with a learning rate of 0.8. All right, and then I run through all this iteration. I call optimizer to minimize my loss function here. And the loss function is the one that I already defined earlier. And then I get the output. And then another thing that you have to notice is that, so for TF tidy, it would only clean up the stuff that got created along the way for computational purpose, but it will not clean up your variables. So if you don't need to keep your variables around, you have to dispose them manually. And OK. And also, what I find a little hard or difficult or confusing using JavaScript is that because you want your whole environment to be somewhat interactive, you don't want to click something and your model starts running and your browser kind of freeze, right? So you will have to learn a lot about asynchronous function. You have to turn something into a generator. Like in this case, I actually write this function as a generator so that it spit out value after every iteration and not like block the whole I/O thing for like a minute or 2 before I can do other stuff. So I think this is the hard part of JavaScript, but for TensorFlow side of things, I think it's pretty much the same as Python. All right, so this is the first part. You build things from scratch. You create one variable at a time. You write your own ops and everything. So this is the approach that we train using a core API. OK, I think I'm going to over my time very soon. OK, the second possibility is to actually use the layer API. As I said, we can do higher level stuff. And in this case, OK, this thing is moving. OK, and for this model, it looks something like this. OK, someone is playing that game. I will demo that game. OK, this is how the model looks like for the high-level model. So basically, if you know something about neural network, there is this theorem called universal approximation theorem. It basically says that a simple neural network with a single hidden layer is actually sufficient to represent any function. So I'll try to prove to you guys that this is sort of true for this easy data set. So I basically create this model with one hidden layer right here. So I just call tf.layers.dense and put in this number of hidden nodes that I want to have inside. Select my activation. In this case, I use ReLU and specify some input shape. And that's it. And then I combine all the hidden layer to my last layer to make prediction. So you create a model this way. You would call tf.sequential because you're trying to add layers sequentially to the model. So you call tf.sequentials, and then you just modify this layer, put everything into array. And that's it. And this is the model. And then I compile the model, tell them to use mean square error, specify the optimizer, and that's it. I got my model. And then here, I just called model.fit. And that's it. And you can specify what is your input data, what's the label. You can specify batch size, epochs, and other details that you generally specify in your TensorFlow Python. And again, to predict, you can just call model.predict, and you get the result that you want. So in this case, let's say, OK, using 8 hidden nodes, it sort of works. Let's see if I try to increase the node, how would that change? So I would update the model and let it start training again. It will start moving and getting good results, hopefully. OK, it kind of stopped here. I can start training another iteration. I just run it again. And hopefully this gets better and better. So we just keep moving, and things should get better. All right, so this is the basic use case of how you could use TensorFlow.js to create model, train the model, and make prediction in your web browser. All right. OK, for the next use case, it would be how we can import existing models and just use it on your web browser. So first of all, you might already have your model in Python somehow. So you first need to save your model. And if you use TensorFlow, you can call the save model builder, and then call builder.save. And that's how you get TensorFlow saved model. But for those Keras users, you can also do the same thing. You can just call model.saveWeights, and that's how you get all the weights of your model. And that's it. So from Python, you now can save the model. After you save the model, you need to convert your model, your parameters, your model topology, and weights into the JavaScript format. So they provide this pip library. You can just call pip install TensorFlow.js. And then you can call this script TensorFlow.js converter to convert TensorFlow saved model into JavaScript format, or call TensorFlow.js converter to convert Keras model to JavaScript model. And once you convert it, now you have your model. It would be a model.json file, and you can simply load that model into your web browser and start working on it. And to load TensorFlow saved model, we would use a function called load frozen model. And the reason for the word frozen is that for TensorFlow saved model, currently they don't allow you to retrain the model. You can only import TensorFlow saved model for making inference. But for Keras model, that mostly built based on high-level APIs, you can call load model, and you can continue training the model on your web browsers. All right. And the script that does model conversion does a bunch of things. It does graph optimization for you. So if the graph that you build in Python has certain nodes that actually not really necessarily for making predictions, it will remove those nodes for you. It does some weight optimization for to save your browser some effort. And currently, it supports most of the common TensorFlow ops, and they're working on supporting control flow ops. And for Keras layers, it supports most of the commonly used one. So there's a good chance that your fancy model, your fancy Keras model that you want to change to convert to JavaScript, it may or may not work, depending on whether you use a lot of custom layer that you created yourself. All right, now I'm going to come back to my part 2, which is to start importing model into the web browser. So in this case, you have seen tons of image object detection models today. You have seen NASNet. You have seen, what else did people use? I don't remember. But in this case, I'll use MobileNet. And the reason is that MobileNet is one of the latest ones that Google open sourced, and the goal is to maximize accuracy while being mindful to restricted resources on mobile device or other embedded applications. So it's very small, low latency, and the accuracy is actually still pretty good. So to use that, as I mentioned, you basically just call tf.loadModel, and you immediately get the model that's ready to use. You can input a photo in there. It would start making prediction right away, interactively on your web browser. I'm going to start generating other random photos. OK, it's a bed. They make a prediction to be a crib, cot, quilt, comforter, still sort of correct. It will make some mistake very soon, I'm sure. OK, military uniform, maybe No, but that's a long code, so that's not right. Okay, switch. Is it switch? No, it's a door, I think. But it's a weird door, though. All right. So yeah, you can put in image. You can do all this object recognition very quickly on your browser. So imagine this. Without TensorFlow.js, you basically have to send this image back to the server, get prediction back, and then use the prediction for something else. And of course, if you want it to be fully interactive, you can turn on your webcam. And I'm not sure if it would recognize anything. Okay, iPod. I don't think there's iPhone in the class for ImageNet. Maybe, oh, cellular phone. Okay, so it sort of works. What else I can do? Microphone. Come on. Yeah, there you go. See? So it sort of work, and you can use this right away. And I heard someone turn on the game. So with this application in mind, Google launched this fun game called Emoji Scavenger Hunt. So basically, this game asks you to find something that looks like the emoji that it's showing up. And I don't really have any props with me today, so hopefully I can show something. Okay, this is easy.
Do I see a fries?
No.
I saw a Band-Aid. Is that a fries? Could that be a fries? Could that be a Band-Aid? Do I see a Band-Aid? Hey, you found it.
Okay. That's just a hand, so hard. Okay. Oops.
Might I see a Band-Aid?
I can't find TV for you here. Sorry. All right. So you. Yes, you see the microphone. That's correct. All right. So that's the idea. So once you can do object recognition, use your creativity, do whatever you want. All right. And okay, now I would go to the second part. Okay. So a lot of people talk about transfer learning. So I'm going to show you how you could do transfer learning as well. So in this example, I'll again load the MobileNet model. And then I would truncate the model. So basically, I intercept, take out the output from one of the layers inside. And I will use that to feed into another model that I would use to make a prediction based on my own classes, right? I think Martin sort of pointed out that if you show things that doesn't have classes specified in ImageNet, chances are it wouldn't give you any good prediction. So if in my apps, in my applications, I know exactly what are the classes that I would like to classify, I can start training my own model to improve the accuracy. So in this case, again, I just use tf.loadModel to load up my model. And as I said, if it's a Keras model, which is in this case, it was a Keras model converted into a TensorFlow.js model. Once you load it, you can still playing around with the model. And in this case, I actually call getLayer to get this name of layer, convolution 13 ReLU. They said they pick it empirically, and this works. So I will take out that layer. And what I'm going to do is I'm going to start training my model with some of the new classes that I want to do. So let's say, sorry, you guys are going to have to see my face a lot today. OK, so let's say class A is my normal thing. I'm not going to do anything. I add some example. OK, it's kind of slow at the first time. OK, so I'm going to move my head around a bit just to make sure that if I move around when I demo you and making a prediction, it sort of know what I'm doing. OK, now class B, let's say it's this. I can tell you that I'm trying to cheat here because class A and class B is so much different. So it will be very easy for the model to learn. But we don't have much time. All right, class C. I'm going to do something. OK, let me tell you, I also got this to work only once this morning before I came here. So hopefully it won't fail on me now. OK, I think that should be good. All right, I collect some data, 3 classes. Now, once you take the model, you basically create your own model. So now you are Predictor Y would be the classes that you want, and we would use a one-hot encoding depending on the number of classes that you have. And then just take the output of so the prediction should be here. Okay, so this is the model. I take the output from that layer that we pull from MobileNet, and then I run it through another hidden layers that have 100 nodes, and then spit out the classes in the last layer. And of course, if you've done MNIST before, the last layer has to use softmax for activation. So now I have my own data. I'm ready to train it. So let me start training. Okay, it always somewhat slow the first time when it initializes thing. Okay. I think it's easy that the loss is already pretty small. I'll let it run for another while so that I won't embarrass myself when I predict. Okay, let's stop that. Okay, now I'm going to try making prediction, and hopefully it works. Okay, this should be class A, me not doing anything. If I hold this up, hopefully it's B. Yes. So I say predict class B, and if I show them my watch, which is my own watch, I didn't borrow it from my friend. Okay, and now it says class C. All right, so this is a quick, small application that you can do everything on your web browser. All right, I think I'm actually exceeding the time a lot already. And some of the application that you could do is something like this. I gave this talk here almost a year ago that you can do image classification if you have an app. Let's say you want to categorize the images that you want to use in your photo. In this case, it's Wong Nai. You want to classify whether it's a photo of a food, a menu, a storefront, or inside the store. You can do all these automatic prediction, or at least recommendation or suggestion, so that your users can pick it much easier. All right, we already went through this. And based on the example that I just showed, you can start training thing on your browser and start controlling games. And the one that they just released with this TensorFlow Summit is this Pac-Man game. But I think I don't have much time. I already exceeded the time. So I'm not going to show you guys this. But basically, you just train whatever action you want to make it an arrow up, arrow down, and you can play this game. It's actually really embarrassing if you're going to play this. OK. I'm going to finish this up. OK, there's also some other interesting examples that built independently from the Google Creative Lab. So one of them that I really like is this Beat Blender. So basically, each corner, OK, let me play this. So each corner is a drum beat of certain style of music. Corner. This for another corner. So that this falls down. And again, this is a generative model. So once it starts learning the style of each drum beat, you can kind of like go find somewhere in between of all this. If this is too boring for you, all right, we don't have much time. But all this is done on a web browser. And the question that you might have, how efficient this is. Is it convincing to actually move things into a web browser? So this is the benchmark from the standard TensorFlow, so TensorFlow Python, on CUDA with this super powerful graphic card, and the one that run on the CPU. So this is the latency of inference time using MobileNet. So it's in milliseconds, so it's actually pretty fast. If you use that graphic card, it's done in 2 milliseconds, 3 milliseconds. So here's where TensorFlow.js lie. So if you use a fancy graphic card, it could be as fast as 10 milliseconds. But if you use TensorFlow.js on laptop like me, it would still be under 100 milliseconds, which is sort of fast enough for interactive applications. And for a lot of you who are JavaScript developer, you probably already do a lot of stuff on Node.js. So they are about to release a wrapper for Node.js very soon. So basically, with Node.js, you can start using TensorFlow with TPU, GPU, and CPU, just like Python wrapper or other languages. All right, so just to recap, we have Ops API Eager. So basically, you can start writing your own TensorFlow model using JavaScript to predict and to train and predict based on your web browser. You can use Layers API to leverage some of the commonly used layers. And then you can import TensorFlow safe models or Keras models to JavaScript pretty easily. And there are tons of demos and examples on GitHub. And actually, a lot of demos that I show you today is simply based on the examples that they have. I just write it in a notebook format so that we can kind of interact with it. And get involved. Go to js.tensorflow.org if you want to learn more about JavaScript with TensorFlow. And all the code is all open source as usual. You can go to GitHub TensorFlow/TensorFlow.js. And if you don't quite understand what I talk about today, oh, I have this. This will happen a lot when you play around with this TensorFlow.js. So if you don't manage your memory correctly, you will kill your WebGL from time to time. So you need to refresh your browser, and it will be up and running again. And if you want more basic stuff, we have this workshop series that Nong James and I taught. So if you want to get a refresher on all these topics, go to www.studio.com. And this was made possible by all these gracious sponsors. And that's it for me today. Thank you. Any questions? No.
What is benefits of TensorFlow.js for server side?
It's basically just for those who prefer to write JavaScript over Python. Me included, so. Any other questions? Yep, there's one in the back.
What happened with our model and data after we refresh the page?
Oh, it's gone.
Okay.
Yeah. It's gone. Is that too bad? I mean, you can always send it back and record it in the server, in your own server or something. You still have the benefit of you finish the training. Let's say if you already have architecture specified, it means that you let user train that model on the browser. So all you need to send back is just weights. And then you can just store weights on your browser. So next time user come up, you can load the weights that they used to have and continue training on that.
Like, is there any possibility that we store it in cookie or session or like?
I'm not sure, but that's a good idea. I think we can probably record some weights and other stuff in cookies. I think so, but I'm not sure. All right. Thank you.